Now we'll see one problem from vibration. Questions are really interesting in vibrations, but if we try to solve, getting the answer is the most difficult part we could ever face. Because if you take each book would have solved using different techniques, but the answers would be same. That's the most important crucial thing while we have solved, while I was preparing. We'd find like each book has the same answer, but they have solved using different techniques. One question in one technique, another question in another technique. So till the last we were not been able to solve this, but after something like popped up, one particular technique can be used for everything, like energy method. So that is like very easy stuff which we can solve, which we can use it to solve this kind of question. We are going to use the same also. Now we'll see how easy it is, because energy method is just like an addition, adding for 10 times. Okay, other techniques are like differentiating, some difficult techniques like differentiating for 2-3 times. So adding 10 times, as far as I am concerned, making you solve is the main objective, right? I am myself solving on the board is not going to be an objective at all. My prime objective is, after seeing this video, you should be able to solve this on your own. Fine. So the question is like, this is a disc in which it rolls on a surface. So once it rolls on a surface, once it is set in pure rolling motion due to this spring and this spring, it's going to go like this. What is the angular frequency? Since they say it is rotating, we'll give a small angular displacement to start up with our calculation, derivation and all. So I'm going to go up with the same axis on the top like this. So in the center. So this is going to be a different diagram, this is going to be a different diagram, this is K1, this is K2, and once this is done, this is 400, this is 100 and all those stuff, let it be. So this is A, and I'm going to displace this over here. How to understand this? So this is a circular disc and we have a point over here. I'm going to rotate it like this. First it was here, now it is over here, A. So and this displacement is with respect to the point it touches the ground, right? So this is going to be from this point. So this is theta, this is x1 for spring 1, this is x2 for spring 2. So from this just solve this. Sin theta equal to opposite by adjacent, opposite x1 r. So x1 equal to r theta since theta is small. Likewise solve it for x2, sin theta equal to opposite by hypotenuse, hypotenuse is 2r. So x2 is going to be 2r theta since theta is small. So now solve it using energy method. Energy method is very simple. Just involve all the forces associated with the particular problem, particular system. So for example, assuming this to be a circular disc, this is not circular. I can catch your mind voice, but assume this to be circular for you to understand. What am I going to do right now is, I am going to rotate as it is. So once you rotate, if it's rotate on a space, actually we know that just like a motor shaft, it's going to be on the same place. But if the same thing rotates on a surface, it's going to move linearly also, because it is now right here in my hand. Once it rotates, it's going to go out. We have a linear movement as well as rotational movement. So linear kinetic energy half mv square, rotational kinetic energy half I omega squared, spring force 1 equal to half K1 x1 squared. Obviously we have spring force 1 and spring force 2. So do you think any other system is involved over here? As far as now, no, we don't have any other thing. Just add up the total energies. So it's going to be E equal to half mv squared plus half I omega squared plus half K1 x1 squared plus half K2 x2 squared. Okay, now one more thing before that, we are going to take all the variables in one thing. For example, we call the single degree of freedom. Even though we have rotational and kinetic, two types of rotation, we call it single degree of freedom, because I can express one in terms of another, this x displacement in terms of theta. So I am going to take everything in the form of theta. So for that, v equal to dx by dt, you all know that. So I am going to take it as x dot. Likewise, I am going to take omega equal to d theta by dt. You all know that it's going to be theta dot. Just I am going to add it up by substituting half m x dot square plus half I theta dot plus half k1 x1 square plus half k2 x2 square. So substituting all those stuff, now this x dot is going to be x1 because it rotates from the center, and this radius is about to be considered for a linear movement of kinetic energy. So now half m x1 is going to be r square theta dot square plus half into I is going to be 1 by 2 mr square. Solid disk moment of inertia 1 by 2 mr square. So theta dot whole bracket for me not to make further mistakes. So 1 by 2 k1 x1 is going to be r theta r1 square theta square. So again 1 by 2 k2 equal to, so x2 is 2r theta. So 2r theta is going to be 4r square theta square. Okay, now just solve this. 1 by 2 this is 1 by 2 mr square theta dot square. So these two are similar, we can add it up. So 1 by 2 and 1 by 2 is 1 by 4. So 1 by 2 plus 1 by 4 is 3 by 4. So 3 by 4 mr square theta dot square plus 1 by 2 k1 r1 square theta square plus 1 by 2 k2. So let's like 4 by 2, I'll take it in r square theta square. Now energy method says that with respect to time energy should be 0. So I am going to differentiate this particular system. So 3 by 4 mr square 2 theta dot into theta double dot, substitution method 1 by 2 into k1 r1 square 2 theta into theta dot plus again 4 by 2 cancels, so we have 2 over here, 2 k2 r2 square into 2 theta into theta dot. So since it's going to be 0, just cancelling out the common terms, theta dot, theta dot, theta dot, r square. So we don't have r1 or r2, I have just written it since it is k1. R square on r square. Any other thing to be cancelled out? Yeah, this is over here 1, 2, 2, 2 out. This is going to be 4. So solving, it's going to be very easy after this. So this is going to be 3 by 2 m theta double dot plus k1 theta plus 4 k2 theta. So we are sensing, we are smelling the SHM simple harmonic motion equation, k1 plus 4 k2 theta dot. Okay, so now our omega would be root of k1 plus 4 k2 divided by 3 by 2m. Okay, so we have got everything. So k1 is there, k2 is there, m is there. After substituting we get 2 into 400 plus 4 into 100, 4 into 100, okay, 4 into 400. So 2 is there, into 2 divided by 3, root of answer is going to get me 23.09 radians per second. So hope you have got the point. It might look like difficult, but if you try to solve many questions, you will be an expert because our concept is same. The method of solving is going to be the same once you are solving many problems in this particular kind of format. So we are about to release a series of tutorial on vibrations also, because people find it difficult to solve this, but it's really easy. Once you see our tutorial, you will be amazed, like, oh, this vibration is so easy. So you are going to feel in that way for sure. So now this is the answer. We'll meet up in the next question.